So, like, I decided to go with the most clickbaity title I could think of. Now it turns out that I don't really have anything concrete to show for it after like 3 months of waiting. So we'll see about a new container runtime, but we will talk about some stuff we've been doing related to containers in systemd, and then what the future could potentially be. Like, what should this look like, or how do we want this to work in today's world? So the story starts really where at work we have our own container runtime at Meta. And this has, I guess this is homegrown, grown over the years. Never really used any of the OCI stuff, right? runc or the other container runtimes. We had our own thing. This has been growing features over time, but like, I mean, as any software, it also accumulates some craft. And so we came up with the idea to see if we could replace this or try to use more systemd to do the sandboxing, the container stuff at Meta so that we don't have to maintain it ourselves. We have like a kind of a weird relationship with OCI, I guess, but we do really like systemd, so that's where the idea came from. Like, let's just use more systemd. So that's the idea behind the trying to get off the old runtime. The other thing that was going on is there's lots of more like use cases coming up where we need specialized runtimes. Some need more sandboxing, some need less sandboxing. Some want a bit namespace, some do not want a bit namespace. Some want username spacing, others do not want username spacing. Some need some specialized BPF stuff, others don't, right? Lots of different use cases, and we wanted a way to be able to satisfy all those use cases on top of a common framework. Instead of having n different runtimes that each for their own specific use case, why not try and have one common framework that all of them can be implemented on top? So when we decided to start doing this, the first thing, when I was asked, like, how can we make this work on top of systemd? Of course, the first thought was systemd-nspawn, right? It's the container runtime in systemd. Why not just use it to make this all work? The problem with nspawn is a very opinionated container runtime. The thing is that you have when you're migrating from something legacy to something very opinionated is that the legacy thing is doing a lot of things that the opinionated thing doesn't want you to do. Our old container runtime was like, for example, mounting /sys as read-write, and that is something that is a big no-no in nspawn. And there's lots more stuff like this that makes it would make migration hard. And would make my life hard when I have to ask Leonard to add a bunch of knobs to nspawn to make it less opinionated so we can make this work. The other problem is that nspawn is purely, well, not purely a CLI-only application. It does also have a configuration file format, but it does not have a nice machine-usable API to spawn containers, right? There is no dbus interface. There is like systemd machined, of course, but then you're effectively using the config file format to configure your container. And there is no varlink API for systemd-nspawn yet either. Then the other issue we had with nspawn is that when you go looking under the hood, the implementation like spawns some worries, I guess. This is kind of, I think this is legacy in systemd probably, where systemd SPID1's own sandboxing and nspawn sandboxing developed as completely disparate systems. So they don't really reuse all or any code. I mean, sure, the low-level helpers are reused, but anything that's got to do with mounting, setting up the sandbox, etc., is implemented separately for both. So if you implement something, a new unit setting for sandboxing in SPID1, or you implement a new option in nspawn for configuring its sandbox, you have to re-implement it or duplicate it in a way for the other one. For example, Leonard is doing all this stuff with nsResourceD for nspawn. If we wanted to make use of that in SPID1 service units, that would require a bunch of extra code. We do use it, but you have to hook it up separately, right? So that's where my problem comes. We implemented a private BPF option as part of this work in systemd in SPID1, and we would have to do a bunch of extra work if we also wanted to support it in nspawn, even though it also makes perfect sense to have that available in nspawn as well, I think. And so yeah, there's not a lot of knobs that allow you to configure the container runtime, and not having knobs makes doing migrations from legacy systems complicated. So we thought, like, what's the other option? Sure, we have systemd-nspawn to provide a container runtime environment, but really a systemd unit also gives you a sandbox environment in which you run a workload. The only thing that was missing is to run a container in it is the pit namespace and the cgroup namespace. Once you can also unshare those, then it becomes perfectly possible to just have a systemd unit with an exec start line that runs user lib systemd systemd in a system mode, and it will run. You will have systemd, and it will pretty much appear like a normal container. How is this different from running nspawn in a unit? Well, if you run nspawn in a unit, then you have the units sandbox environment in which you run nspawn, which sets up another sandbox environment which runs the actual container. And to me, this always seems philosophically kind of weird. Like, why would you have two sandbox environments inside of each other? Can we just make the first one do the thing we need and then just run the workload inside of it? And that's where the idea came from, to basically add the necessary unit settings to systemd so you could run a container inside of it. And like, a container is really, it's kind of a nebulous concept. It's more like a combination of namespaces that, and then you give it the name container. I think the distinction these days is probably made between having the pit namespace or not. If you have the pit namespace, I think you call it a container. Otherwise, it's just a sandbox. So we did all the work to add this. The private bits will give you the pit namespace. Implementing that was kind of easy, except that you have to fork to get a pit1 in the pit namespace. So we had to do some nastiness around that to make that work. cgroup namespace was trivial, or so we thought, and then we tried to use the delegate subgroup option, and it turned out to be not so easy. But we fixed all that, so pit namespace and cgroup namespace supported. And then the other thing you want in a container is you wanted to have control, you generally wanted to have control over its own namespaces. So like, when you're in a container, you expect generally to be able to do mounts, right? Not the disk image kind of mounts, but like a bind mount, a tempfs mount, all those kinds of things is something you expect to be able to do. You can only do that if your user namespace owns the mount namespace. So we had to, by default, this is not the case in a systemd unit. So we had to add a setting to make that possible, and that is delegate namespaces. If you enable that, by default, the user namespace will not own any of the other namespaces. If you enable that option, you can switch it around and make sure that the user namespace owns all the namespaces, which means you can do all kinds of fun stuff. This takes a Boolean, or this takes an individual list of namespaces, so you get fine-grained control over which namespaces are owned by the user namespace and which ones are not. And then the final thing I did, we don't use this yet, I think, but so I also made sure that the notify socket for notify messages from the unit is mounted to the correct location inside the sandbox, so that the systemd running in the unit can send progress messages to systemd outside of the unit for progress updates, the type equals notify stuff, and all that. What does this look like? Well, here you have it. This is from the integration test. So this is what I said, I don't really have any proper usable thing to show you. Like, this is not exactly a good UX. It is good for our internal use case, because like you see with all these options, you get a lot of control. So you can turn things off and on, individually configure things. It makes it easy to migrate from something legacy. But as a user, like, this is not what you want to be writing to start your container. So the question is, can we improve on this somehow? And what do we do with nspawn then? And do we need to like support both? So there's like lots of questions I have around this. What do we miss in transient units at the moment? And this again gets into the duplicate implementation, right? So sure, we can run a container now in service units, but we do miss some stuff from nspawn, right? All the networking setup that you have in nspawn, you don't have that in systemd units. And maybe you should, right? Why shouldn't you be able to configure the network namespace of your unit with some virtual Ethernet device or some port forwarding or all that? We don't have the advanced user NS setup, so we don't have the NS resource D integration. We don't have ID mapped bind mounts like nspawn does that. It does them. We don't have the bind user switch. So there's quite a bit of stuff missing, and we don't have like a high-level API for the transient unit type of container. So like I mentioned, the technical debt behind the scenes with the missing code sharing. And the other thing that comes along with this is that if you run an nspawn container with the CLI, then you get the you automatically inherit the execution context. If you start a container from a transient service unit, then you do not inherit the execution context. And the two are tied together in a way. Sure, you can run nspawn in a service unit, but then you lose a bunch of other niceties. So I'm wondering, like, should these things be tied together, or should you be able to mix and match, right? Use either nspawn with execution inheritance or not, and use maybe a transient unit with either one of these. So how would we fix this? Like, how can we actually make nspawn, or can we actually make nspawn and units use the same backend to do their sandboxing? Because, like I said, there's a lot of duplication here, but we should be able to have a unified thing that actually does both. So we have this thing in systemd these days, which is called systemd-executor. And the reason this was invented or added is that systemd, when it starts the service, it does like any, I don't know, process spawning service init thing does on Linux, which is it does a fork. And then it runs a whole bunch of code in the fork to set up the execution environment, and then it executes the actual binary. Now, running code after fork is frowned upon, I would say. And then if you follow pure POSIX, then you probably should not run any code after fork. With glibc, you can run more code after fork, but it's still like, there's like, how do you say it? There's lots of sharp edges and problems that you can run into. So we added systemd-executor, which contains all the code we used to run after fork, but in a separate binary. And so we do a fork, and then we immediately exec that binary, and suddenly running all that same code is perfectly fine. Don't ask me why it's the case. It is the case, so that's what we do. It allows us to even not use fork, but something called vfork, which is more efficient because it doesn't share memory between the two processes. So we have that, and then to communicate with it, there's a very bespoke serialization format, very arcane. You would never want to use it for anything else. Like it's one of the biggest bits of legacy in systemd probably, but it is there. So the question is, can we make systemd-executor into a more generic tool that can support both the use cases? Can we turn it into something that could be used by systemd-nspawn? The advantage would be that if we had that, then we could implement a feature once in systemd-executor, and then we would only have to write up a little bit of glue logic in nspawn and in systemd-pid1 to enable the feature for both use cases. So how would we achieve that? Well, first we would switch from the bespoke serialization format to JSON. We would give it a varlink interface because, again, there's a very weird, complicated dance between pid1 and systemd-executor right now. It inherits a lot of file descriptors, and then you have to close some of them at some point of time, or you have to do other stuff, or you have to send file descriptors to Unix sockets opened by systemd to communicate all the necessary information. Like, this is not an IPC that you want to implement in nspawn. You want to tighten that up some more, give it like a proper interface, maybe even document it, maybe even make it public, but that's a different question altogether. Maybe even give it a CLI interface, right? I know, like, right, we tend to, I don't think we hate on bubble wrap, but like, I always thought bubble wrap does have, like, it has its issues, I think, but it does have a very nice CLI interface for setting up a sandbox. So maybe we should implement the same so you can like easily test it, right? Set me up a sandbox, give me these bind mounts, etc. So you can test it out. So that would give you basically this, right? Systemd-nspawn can call out to executor, and systemd can call out to executor, and you can share the features. But then you still don't have like a systemd-nspawn that can set up a container without inheriting the execution context. So the question is, like, should there be a way to do that as well? Should systemd-nspawn be able to invoke systemd-executor via systemd so that it can have a way to set up a container without inheriting any of the execution context that it is running from? This is an idea. I don't know if it's a good idea or not. You could even maybe have a systemd-executor.socket if it is a varlink service anyway, to expose it as a varlink activated, socket activated service. Would it make sense or not? I'm not sure, but it's an idea I had. What about the high-level API then? So we have a few things in systemd to have high-level management of containers. There is systemd machined, there is systemd importee. Machined will manage running containers, importee will manage images for you. Currently, the containers live in varlet machines, but there does not seem to be a distinction between images and the containers running off of them. So if you start a container of an image in varlet machines, then it can modify it at will instead of creating a copy of that and then working on that. Yes, we have an ephemeral switch, so it does make the copy, but then when you shut down the container, the copy is gone. The question is, should you have a distinction between those so that you can copy an image, start a container off of it, shut it down, start it again, and not lose your state? This is basically how Docker and Podman do the organization. I think it makes sense. We should probably have the same distinction. You can configure nspawn with some config files that you drop into the usual location, but I've never heard of anyone actually using that. Oh, so okay, well, people do use it. Then we have import cuddle to download images from a given URL to varlet machines, but there is no real discoverability of images, right? You can't tell, like, you list me all the images in this namespace or stuff like that. There is no support for a registry. I'm thinking we should probably have that if we want this to be an alternative to Docker or Podman. So the individual parts are there. Like, I think we support most of the common operations that Podman and Docker also support, but there doesn't seem to be like a nice UX to the whole thing. And so that made me think, should we really be implementing custom CLI interfaces for all of this? Or should we just like re-implement the Docker interface? Because everyone is going to know the Docker interface anyway. So why shouldn't we just provide the same thing and give people an easy way to adopt our stuff if they want to do so? And Podman basically did just that. They re-implemented the Docker CLI. They re-implemented even the Docker API socket. And people seem to really like that part about Podman. So what is coming soon in the like high-level world is that Leonard is doing a lot of work on making machined and importee run as user sessions. So you can suddenly start using all of this stuff unprivileged, right? Currently, for all these operations, you need root, which makes it a pain to work with, but it's soon going to become available as an unprivileged daemon running in your user session. So you can certainly also with work on nspawn that Leonard is doing to make it run unprivileged. We're going to get unprivileged containers soon. So there is work going on in this area to improve it, but I think there's still a lot more work left to be done. That was everything. Thank you for listening.
So, systemd docker dwen. Any questions? Any comments? Yes. Come closer, please.
I was wondering if it would make sense to have some kind of OCI converter that talks to the generator or executor. What is the name again?
Generator, I guess. So Podman has this with Podman quadlets these days, I think, which are basically a generator for systemd units that take a high-level container description and map it to a way to run it in a systemd unit. People really seem to like that. I think we probably want something in that vein, but Leonard has thoughts on this as well.
So one thing that I have on my list for the current systemd cycle that I would like to implement, but I'm not sure if I can actually deliver because we shortened our cycle so much, is I actually want to do pretty much that, right? Like I want to, I mean, OCI has many shortcomings in my view, but also of course this thing, right? And so I wanted to just make that work, and so that you can run OCI natively with systemd behavior, and it's very close to what Daan just described, but I'm always like in my head like going forth and back how this should actually look like in the end, because you know what Daan suggested, like there's two ways how you can do it. Like you can fork it off as a via systemd-executor, or you can talk to p81, which will then fork off systemd-executor. But for me, I was also thinking, you know, I really like the pattern of portable D, right? Like that you have the stuff prepared ahead of time. You just drop the native stuff in Etsy, and then then it's there, and you do not need any further runtime conversion or anything like this. So this is like a third way how to start such stuff, right? Like, so instead of doing it at runtime via the child or at runtime via P81, you do it ahead of time by dropping in native unit files that you generate from the OCI stuff, and then the OCI stuff just becomes this installation step and not the runtime step. And I really like that thing. So this complicates things further, and I still haven't figured out how this will work in the end. But yeah, it's definitely something I want to do. But it explodes into this big problem because we first have to be able to do like units and encode them properly in JSON. Because that's probably what we want, because we want to transfer it via varlink, because we want to communicate the serialization in a sensible format to the executor, and things like this. So yeah, it's definitely constantly on my mind how to do this best. And yes, I definitely want to make OCI workable. But I mean, again, like, I don't want people to actually think that OCI is a great invention. I think it has so many shortcomings, but I also understand that this is what people use, right? So yeah, I'm figuring out how to make this like a systemd thing and make it really good. But yeah.
I was wondering if this would allow running systemd inside portable services. I think it kind of lines up with what Leonard was saying, but like, could I run systemd as PID1 inside a portable service and use that as the high-level interface to describe this?
I'll let Leonard answer that one. I'm not sure, actually.
So you pretty much can already do that. Like, the unanswered question is what to do about the console, right? Like, one thing that nspawn does, it gives you the way how you can interactively talk to your container. And so if we fork it off P81, then you won't really have that. So that feels very different. And probably we need to figure out how to do that at all, right? Like, because if we make P81 run the containers and systemd inside of it and showing you a getty prompt and things like that, then we need the interactivity somehow. But that interactivity cannot really live in P81 because P81 doesn't have a head, so to speak. So yeah, anyway, we have to figure things out there.
You showed on this, not the demo slide, you showed the delegate namespaces stuff, and you showed capability trimming, I think, for like trimming specific capabilities. So yeah, that one. Like you say, capability bounding set only this stuff. I don't really understand. I think that means I don't understand delegate namespaces. Like that, it sounded like delegate namespaces means that the thing in the container can control this kind of stuff. No.
Yes.
So how do you prevent them from messing with this and like extending it again to catnet admin or something?
Yes, I'm not sure namespaces and capabilities are related. I'm looking at Christian. Like the namespaces don't give you control over capabilities, right?
True, I guess. Sorry.
Yeah, the user namespace does. So the delegate namespace is like, it's not more so much about capabilities, it's more about being able to do mounts or not, if it's the mount namespace, being able to configure your VAT network devices if it's about the network namespace, being able to set the time if it's about a time namespace, being able to set the host name if it's about the host name namespace, and so forth.
Okay, so you kind of need both. You need so it sounds like you need both. You need the namespace and you need the capability, and then you can.
Yes, but the capabilities are namespaced by the user namespace, so like they do interact in that way. If you unshare the user namespace, then you already have your own separate set of capabilities anyway, which you can still drop, but they're already a lot less useful after you unshare the user namespace, because they won't affect the host namespaces anymore. They will affect only what's controlled by that user namespace.
I have a question about what you currently support running application containers already with systemd-nspawn, right?
Yes.
And you do, when you want to get a shell in there, you like a stub init binary that you get the shell from? Version, essentially, no.
Why did we?
You connect via dburst or something to P81 inside of the container and ask it to give you a shell, and you give it a file descriptor and it gives a shell. Yeah, I mean, that's what machined does. But I mean, yeah, we have to figure that out too, like something else there, right? Like make something like unshare, like the shell utility unshare work, as a fallback for the cases where there's no PID1 inside there. Because there usually isn't something useful in OCI containers.
Are you planning support for pass-through of GPUs, NPUs, TPUs, whatever? But Docker does a lot. I mean, in the end, but yeah.
The answer is no, I am not planning any of that.
Send a PR.
So we did this in, we did like the keeps turning off. We did the device pass-through stuff in formerly LXD, now Incus for a while. So we allow you to move like GPUs and all that kind of stuff. But the problem is that it's not namespace. And so this is kind of wonky, right? Because let's say you plug in a device to the container like a GPU, and you won't get any view events or so on, which probably for some workloads doesn't matter, but it's like, it's really unclean the way this is currently done. And you can make it work because like we know, a lot of people know, it's like you can inject view events, like you can actually forward them. This is something that I kept from Leonard for a long time, so he doesn't hate me, but it's essentially like you can receive view events on the container when you get device events for GPUs, and then you can listen on these view events, and then you can like literally send them into the container, and the kernel will append a new sequence number, and then you sort of can mock device namespaces, because then you suddenly, inside of the container, you get notified about view events, but it's still very unclean, because obviously sysfs is a namespace, so it's really dirty, and the proper solution would be something like a device namespace in the kernel, which is like would be a massive amount of work and with questionable outcome, like if this would ever make it upstream.
So the official stance of systemd is that it's a kernel problem. Once we have a device namespace, sure, but I don't think we will ever get that.
All right, that is all the time we have. So let's thank Dan again. Thank you.